let's take a look at rational inequalities using TI-89 calculator. This is www.mathheals.com, and you can find more links to YouTube math videos out here. If you go to Graphing Calculators /technology, and then go to College Algebra, these are all the different topics you can do on the Graphing Calculator in College Algebra. And I'm working my way through all the different calculators. If you need more help on a particular topic, if you go to Math Lectures, and then go to College Algebra, and then you could watch whatever YouTube video you want. If you want to know more about quadratic equations, watch that YouTube video. This is the exact same lecture, same explanation, same examples given in the classroom. It's not watered down at all. Don't watch WebEx. I'm eventually going to remove those. That was before I knew how to do YouTube. Okay. Let's take a look at rational inequalities. So solving rational inequalities. Our first step is get everything on the left side, 0 on the right side. Step 2, get a single fraction. Rational means single fraction. Step 3, factor the top, factor the bottom. Then set each factor equal to 0 and solve. And these are critical values. And in step 4, using the x-axis, your critical values, and the graph, then determine your answer. Less than or less than or equal to, your answer is below the x-axis. If you have a greater than or equal to, your answer is above the x-axis. If you have a less than or greater than, you're going to use parentheses. If you have a less than or equal to or greater than or equal to, you'll use brackets. There we go. Guess I don't have room for the title on there, but that'll be enough. So let's look at our first problem. We got x plus 3 over x minus 1 is greater than 0. Step 1, get everything on left side, 0 on the right side. Well, that's done. Step 2, get a single fraction. We have a single fraction, that's done. Step 3, factor the top, factor the bottom, then set each factor equal to 0 and solve. Well, I can't factor these, they're pretty basic. So I'll set each one of them equal to 0 and solve. So we got x plus 3 equal to 0 and x minus 1 equal to 0. And we got x is equal to negative 3, and we got x is equal to positive 1. Now those are our critical values. Step 4, using the x-axis. So here's the x-axis. Our critical values, our first critical value is negative 3. So I'll put negative 3 here, and I'll put 1 here. Now the critical values should go from smallest to largest. And they split this into intervals. So this negative 3 splits an interval, and this 1 does also. Now clear over here is negative infinity, and clear over here is positive infinity. So this first interval is negative infinity to negative 3. The second interval is negative 3 to 1. And this last interval is 1 to positive infinity. Then it says also end the graph, then determine your answer. Remember, when you graph a rational in your calculator, if you have more than a single number, a single variable on top or bottom, you have to put parentheses around that part. So we'll put parentheses around the top, we'll put parentheses around the bottom. So let's go ahead and graph this. Okay, so I'm going to do diamond F1 for y equals, up arrow, press clear, do a beginning parentheses, x plus 3, closing parentheses, divided by, beginning parentheses, x minus 1, closing parentheses, and then press enter. Okay, now I'm going to do a graph, so I do diamond F3, and our critical value is where it changes, from above the x-axis to below. -3 is somewhere here. If I look to the left of it, I see it's above and part of it, so it has to be above in all of it. So it's above in this interval. Now between -3 and 1, well, -3 is here and 1's right here. I see it's below the x-axis, so it's below. Now greater than 1 over here, I can see it's above the x-axis, so this will be above. We could care less what the graph really looks like. All we're trying to do is identify above and below for those intervals. Okay. Now for this problem, we have a greater than, and it says greater than, your answer is above the x-axis. So I look where my graph is above the x-axis, which is right here and right here. So those two intervals are our answers. Now this interval is -infinity to -3, and this interval is 1 to +infinity. Now infinities always have parentheses on them. Greater than says we're going to use parentheses. So that means I put parentheses on -3 and 1, and if you got two intervals, you connect them with a union symbol. And that's our answer. Let's look at our next example. We've got x over x minus 3 is greater than or equal to 2. Okay, first step, get everything on the left side, 0 on the right side. So we're going to take this -2, move it to the left side. This is step 1. So we got x over x minus 3 minus 2 is greater than or equal to 0. Step 2, get a single fraction. Well, remember when we had a mixed number, 3.5? To simplify that, we take 3 times 2, and then we add to 1. So 3 times 2 and add to 1, and then our denominator stayed as is. So we took the number to the side, multiplied times our denominator, and added our numerator. Well, this one's no different. We got a fraction and a number to the side. So we're going to take our -2, we're going to multiply it times our denominator, so multiply it times the x minus 3, and we'll add the numerator. So -2 times the denominator and added the numerator. Let me try it again. I got a little bad place on my tablet. And then our denominator stayed as is. So this stayed x minus 3. Greater than or equal to 0. Okay, multiply the -2 through. -2 times x is -2x. -2 times -3 is a +6. Plus x over x minus 3 is greater than or equal to 0. -2x plus x is -x plus 6 over x minus 3 is greater than or equal to 0. We got our single fraction. Step 3, factor the top, factor the bottom. On this particular problem here, there's nothing to factor on top or bottom. I can factor a -1 out of the top. Remember, GCF-wise, if your first term is negative, you can always factor out a negative. But it probably wouldn't help me very much on this. So I'm going to go directly to setting those equal to 0. So I got -x plus 6 equal to 0, and x minus 3 equal to 0. Here I'll take -x over, so we got 6 equals x, and here I'll take -3 over, and we get x is equal to 3. Okay, step 4. Using our x-axis, so here's our x-axis, our critical values, here's 3 and here's 6. We want our smaller critical value here, larger one here. Remember, these split them up in intervals, so that's splitting it up in intervals. Clear over here is -infinity, clear over here is +infinity. And the graph. Now, I want a graph where one of these cases where 0 is on the right side. So you don't want to choose the original problem. But I'm going to choose this step right here. Remember our key to this is if you got more than a single number, a single variable on top or bottom, you put parentheses around that part. So put parentheses around the top, parentheses around the bottom. So let's go see what that looks like. So I'm going to do diamond F1, up arrow, clear on Y1. Then I'll put a beginning parentheses, negative x, plus 6, closing parentheses, divided by, beginning parentheses, x minus 3, and then closing parentheses, and then enter. And now I want a graph, so do diamond F3. And that's going to be our graph. Okay. We said something's happened at 3 and 6. Well, here's 3, and to the left of it, I see it's below the x-axis. So this will be below here. Now let's look at between 3 and 6. Here's 3, and 6 is somewhere here. I see it's above and part of it. If it's above and part of it, it's above and all of it. And then greater than 6. Well, 6 is somewhere here, and to the right of it, I see part of it's below, which means all of it has to be below. So that's what we got. Now, we got a greater than or equal to. So our problem says greater than or equal to, your answer is above the x-axis. Well, the graph is above the x-axis in this interval from 3 to 6. Okay, greater than or equal to. Down here, it's greater than or equal to says brackets. So I'm going to put a bracket on the 6, and I'll put a parentheses on the 3. And that's our answer. Note, if you have any critical value that comes from the denominator always has a parentheses on it. So any critical value that comes from the denominator always has a parentheses on it. Think where that 3 came from. The 3 came from the denominator, didn't it? And if I were to plug 3 back in, 3 minus 3 is 0. We'd have 0 in the denominator. We can't have that. So again, any critical value that comes from the denominator always has a parentheses on it. Always get that question. I'll work this problem, and then it's not too often that I don't have some students say, why did you change? Why did you put a parentheses there? Which is good. They're not just blindly copying down the problem, but they're thinking through the process. And then I ask them why that would occur. And some of them see it, and then some don't. That's solving rational inequalities on a TI-89 calculator.